Hello, everyone. Welcome back to the AAS YouTube channel. And this is part of the good stuff. This is the AAS Journal Author Series. And I am super happy to have Tracy Chen and Frozen Marion Schmitz with us today.
Hi, Frank. Thanks for
Hey,
having
Tracy.
us.
Well, thank you so much for being willing to talk about your very cool article. That's great. Tracy, where are you located at?
I'm in Pasadena, California.
Yeah, very cool. And Marion?
I'm also at Caltech in Pasadena.
Okay. Did both of you go to AAS 240 there in Pasadena in June of 2022?
Yeah.
I did not.
Okay.
I certainly was, yes.
Yes, I went there too. I was on the exhibit floor, all masked up and everything, but it was it was good to finally get out, meet people in person in a AAS meeting. So it was very cool. Very nice. Let's see. And Tracy, what do you like to do? What are your interests in astronomy?
When I was doing my PhD and doing my postdoc, I worked on the WMAP and the PUNC data, mainly to develop algorithm to separate the CNV foreground contamination from the beautiful background. So nowadays, I'm actually a scientific analyst working for the NASA IPAC Extragalactic Database, NED, and also the NASA Exoplanet Science Institute.
Nice, very cool.
Yeah, I help with the data ingestion process, the validation of literature data, and to put them in the database, those kind of things.
Cool, very cool. And Marion, what do you like to do?
Well, for the last 35 years, I've also been working on NED and been transforming the data from the refereed literature into the database so that there is a database that can be accessed.
Right.
For 20 years, I was also the chair of the IU working group on nomenclature. So I've got more experience with that.
Very cool. Very cool. Well, it seems like you two are the right pair to be talking about this. So very nice. And that is going to bring us to this very awesome APJ supplement article. It's open access, people. You can go grab it for free, go get a copy, and most important on this one, apply it. So best practices for data publication in the astronomical literature. And Tracy and Marion, take us away.
Okay, thank you. So this is the best practices for data publication in the astronomical literature. First of all, I would like to give a shout out to all my wonderful co-authors who have provided so much valuable suggestions and help along the way and ultimately made this paper possible. You can see this is a joint effort from multiple major astronomy databases around the globe, including NED, ERSA, NASA Exoplanet Archive, COA, ADS, CDS, HESARC, Chandra, MAST, and also publishers, including the AAS Journals and the Oxford University Press.
Very cool.
And I have my co-author Marion here. I specifically invited him because he's actually one of the original people who initiated this idea of providing a set of guidelines on data publishing well over 10 years ago. So he'll be the guy to answer all the questions you may have about the history of this document and how it evolves throughout the years.
Very cool. And we'll be, of course, interested in the end, in the future, how we do all this and actually do it. So very cool. So good shot. Okay.
Yeah. So this paper is motivated by two of the scientific needs we identified of the astronomy community. So on one hand, we all know that modern telescopes and instruments are collecting more complex, larger volume of observation data at a much faster speed. Yeah. So this is directly reflected in the ever-increasing number of articles being published in astronomical journals each year. You probably know more about that. Mm-hmm. So therefore, it is important that this data are prepared and published in a way that will not only represent and support the scientific claims of the paper well, but also enable better data sharing, make it easier for other people to reproduce the results and to reuse the data for follow-up studies.
Excellent. Science 101 there. Mm-hmm.
Yeah. And on the other hand, This data are also continuously being ingested into astronomy databases. That's what we do. As you can probably imagine, clean and accurately represented data will greatly help streamline the whole extraction, integration, and the cross-linking of data from the literature into the database.
Right.
So this will in turn enable new data analysis, help with the planning for new observations, and subsequently contribute to new scientific discoveries.
Yep, absolutely.
So for most of us who work either for the data centers or for the publishing side, we are at a unique position to view and work with a large amount of literature data on a daily basis. So we acknowledge that a lot of the authors do present their data with great care. We thank you for doing that. But we also see a substantial number of articles published each year with all sorts of different issues that really hinder the scientific goals and degrade the quality and utility of the data.
Right.
Therefore, we came up with the set of best practices for publishing data and metadata in astronomical journals. So I just want to point out that much of the recommendations here also reflect the FAIR principles for scientific data management.
Right.
That is to make the data findable, accessible, interoperable, and reusable. So we hope it will be a useful reference for all the authors, referees, editors, and publishers. So we believe that by following these guidelines through the different stages of publication process, it will really enhance the representation, data sharing, reproducibility, and reusability of the data.
Right. And I would like to particularly point out this will be extra important as we all head into the era of open access here one way or the other. Journals have made that transition and it will soon be mandated from various agencies. And so I think the timing here for getting good data practices is ripe.
That's right. So moving on to this best practices. So in this section, we provided guidelines for presenting data in many different areas of astrophysical research. But before we discuss the recommendations for the fundamental data, such as names, positions, photometry redshift, I just want to go through some general rules that apply to all.
Yes.
First off, define your symbols, define the acronyms. Astronomers are known to create all sorts of acronyms that we can't possibly keep track of ourselves.
Sure.
So it's very important to define them in your article, at least the first time when it's occurred in your article, to avoid confusion. And when reporting any new measurements, we ask the authors to please provide the uncertainties and the confidence level, as that will make the reported measurements more meaningful.
Oh, boy, I really don't like this notation. I hate that.
Yes, we give examples of.
I can't tell what it means.
Yes. we see authors do that, and it is really confusing.
Mm-hmm.
Yes. So another thing we want to emphasize is to have authors to please only include the appropriate number of significant figures that match the precision of your measurement. We actually see this very often because modern data are mostly generated from floating point machine computation.
Right. It's
so easy to just dump that number from your computing program without thinking if it is really an accuracy that can be achieved by the instrument.
Oh, everything is 16 significant figures, isn't it?
Yep. So I mean, there are a lot of things here. I'm not going to go through every single bullet point here.
Sure.
I'll just select a few points in different categories to talk about.
Okay.
So moving on to the next page.
Yeah.
So first, nomenclature.
Okay.
I think we can all agree that this is the most common and basic type of data for any astronomical object. It identifies the source. There are a number of IAU documentations on how to name a new object or to check for correct acronyms and formats for known objects. We would definitely recommend authors to go over those when you're preparing your manuscripts. And additionally, we want to emphasize that authors to please provide the complete object name, as the truncated name can be very confusing. If you can go to the top of this page, there's a table.
Yes.
Yeah, the very first example here, if you see this SDSS name,
common.
this truncated name can easily be any of the 3 different nearby sources we present here on the right. So which one is the intended one that the author wants to discuss in the paper?
Right.
Yeah.
Right.
So there are some other examples here of the incorrect representations of names in journal articles that we see over the years. Yeah, all different ones. So all this will cause misinterpretation of the data presented in the data article.
Yikes. Yeah, and I would like to make a point at that the AAS journals, we do follow IAU conventions on names and things. So you can't just make up your own name. Joe Star, Sally Star. No, you have to use the proper IAU convention. So very good. Oh yeah, I've seen many of these.
Yes. So another thing I want to mention is for known objects, we really discourage authors to keep creating new names. In that, we actually would have an object have like, I don't know, 100 cross IDs. This is really unnecessary, adds confusion, and also not giving proper credit to the people who made the original discovery. And when using existing names, we advise the authors to please check for the correct formatting of names. There's actually a tool called Sesame, hosted by CDS.
Oh yeah.
It will query NAD, Singbad, and Vizier to help resolve those object names. And one last point I want to stress here, it's under the cross identification, is that when authors present the same objects in multiple tables within the same article, but with different names. This happens. It's, for example, like, it's data from different observations. So therefore, like, those objects are associated with different observation ID in different table. I mean, we understand that happens. But if the authors could cross-match these objects, that would really help the readers to better access related data about the same objects.
Right.
So next, astrometry.
Oh,
another very essential attribute for astronomy, astronomical sources, as we need to know where the objects are in the sky. So we ask the authors to provide the best available coordinates with its reference system, the equinox, observation wavelength range, as all those informations are very important for follow-up observations and study.
Yes.
All that. We just put a little note at the bottom there. We caution that although the standard equinox and app are currently in use are J2000, but when citing coordinates from a catalog and article, don't always assume that's the case. Example here, Gaia, different releases using different epoch.
Right.
Just always make sure you check the original source for the correct equinox epoch.
Right, because many of us have gone back to older papers, let's say in the 1950s and 1960s and so on and so forth. And it's not always clear what the epoch and equinox are. And so to put that forward, if you put your article in now, 50 years from now, you want people to be able to go back and tell exactly what the equinox and epoch was, not the common convention at the time, because those people aren't here anymore. So.
Okay, moving on to photometry. So it's very important that authors would describe the method they use to obtain the photometry. If it's from a PSF fitting or from aperture photometry, and if it's the latter, what are the size of the aperture, what kind of corrections you applied to the flux. And authors are advised to use the standard passband filter identifiers. Don't try to abbreviate it, as it will definitely introduce confusion.
Correct.
An example we give here is that by using a single letter B, B band, do you mean the Johnson B or Cousins B? So gave the full name.
Mhm.
And we also provide some resource here for authors to look for the standard identifiers.
Oh, good.
There's this
Okay.
Spanish Virtual Observatory Filter Profile Service that we recommend authors to go check for the correct names of those filters. Similarly,
Yes.
I'm just gonna jump to the redshift part because I'm not going through every single part of this article.
That's good. I think
So
everybody
for yeah, if you could just go to 2.5, section
Yep.
2.5, redshift.
Mhm.
Yeah. So for redshift data, same thing. It's important to let the readers know what method you use to obtain the redshift, if it's spectroscopic or photometric or some other methods. And what are the reference frame for those measurements? Is it heliocentric or barycentric? And also the quality of the measurement. Is it robust or is it a questionable one? And all this information are very helpful for the readers to understand and reuse the data.
Absolutely. I think everybody should post this article on their board over their desk. That's a good idea.
So next, I'm going to just jump to the data presentation. I mean, there are a lot of other recommendations on time, orbital parameters. I'm not going to go through all of them. Jumping to data presentation. So observational data are mostly published in the forms of tables and figures in an article. So for tabular data, we recommend authors to clearly label the different columns, explain the content for each column, and keep each column homogeneous. That is to please do not mix arrows with the limits or comments or append flags to values. If you can move to table 2.
Yeah, let's see an example.
Yeah. So on the left-hand side of this table, you can see this redshift column. It does not just provide the redshift values, it also mixed with some quality flags,
right,
using the LaTeX markups. And this is discouraged as the markups are not easily parsed by computer programs. Therefore, it will degrade the reusability of the data. And it's better to avoid these markups and just use numeric values in an additional column to indicate quality, as shown on the right side of this table.
No good.
And another common bad practice is that people like to use numeric values such as -999 or 0.0 to indicate a null value.
Null value, right.
We ask also, please just use a NaN or null because it's so easy to treat, like those actual numeric values can easily be treated by the computer as a legitimate numeric values and cause wrong computational results.
Indeed.
And then for graphic representation of data, we suggest authors to try include the data behind the plots. That is to make the data used to generate the plots publicly available. This will enhance the ability to reproduce and validate and also build upon those published results.
Correct.
And try make those graphics accessible. If you can go to the figure we're showing here, you can use different symbols and line styles in addition to colors in your plots. And this will help a broader audience to properly understand the information conveyed in these plots. The AAS Journal's graphics guide actually has more advice on this. So I would refer authors to go read that graphics guide from AAS Journals when creating your figures.
Right.
So
for those of us who remember when figures were not color, right? And line type was how you distinguished between different quantities. So here you do both. So very good.
So moving on to the next section, to archive your data and ensure long-term access. So here our recommendation is to for authors to either append small data sets as part of your publication, or if your data sets is big, deposit them at well-established data centers, preferably those that issues DOIs. We'll come back to DOIs later. But do not publish your data at URLs lacking long-term support, such as your personal web server. One study actually has showed that in 2011, about half of the data links, close to 50% of the data links published in the astronomical literature 10 years earlier were broken.
Sure.
So that makes it impossible for future researchers to retrieve and reuse the data. So to facilitate the authors, we actually assembled in Appendix B a list of established astronomy databases that support long-term storage and access to scientific data.
That's
this list, yes, Appendix B, it's okay. You don't have to move it all the way there.
That's okay.
But
okay.
Good. So we have it there. I mean, it's not a complete list, but it's a good start point for authors to go and choose like different databases and choose the one that fits their data type and the needs the best.
Right. That's a nice listing in case anybody was wondering where your data should go, not on your home website.
There's a lot of choices. Just
That's
don't
good.
put it on your
Choices
home
are good.
website.
Choices are good.
Yeah.
Okay.
So next, we provided some recommendations on how to properly cite data in an article. So for example, one should always cite the original references using the preferred citations provided by the author, if available. And when possible, try give the full provenance of the data. Like, well, is the data originally from? Well, is it stored at? How is it retrieved? And what software and which version of the software is used to analyze the data? This will ensure full reproducibility of the analysis. And similarly, proper credits should be given to the facility, such as a telescope and instruments or services used to obtain the data, such as the databases where the data were retrieved. So AAS actually created a vocabulary of facility keywords that makes it easier for authors to credit facilities in their articles. Yep.
Yeah, I just want to hammer a little bit on citing the original references. You see a lot of this where somebody will write like an annual review article, right? So the annual review article gets cited, but it doesn't contain any of the original data. So it's always good to go back and cite the people who actually took the data that enabled that annual review article or something like that. So
yeah, and if you have data from other work and data from your own work, just make sure you differentiate them in your paper.
And I think a lot of this goes not just for a lot of this applies not just to data, but to software as well.
Yes.
There's a lot of commonality here with this stuff.
Yep. So that's the next section for
software. How about
that? Same thing. Please cite the software, list the version used, and use the preferred citation if available. So last but not least, DOIs. We had talked about this earlier. They provide a persistent and unique identification of your specific data sets or software or services used to produce the results in the published articles. So again, deposit your data in an archive that issues DOIs.
Right.
And if available, try to use the DOIs to cite the related content in your paper. Last but not the least, try tag your articles with relevant data content keywords from the Unified Astronomy Thesaurus. This will greatly enhance the filtering and searching of literature articles. So that will bring me to the summary. We provided a bunch of recommendations on different aspects of the data presentation and publication in astronomy journals. We know it's a lot to take in and keep track. So we provide a checklist in Appendix, Appendix A for easy reference. So we really encourage that all the authors, referees, science editors to consult this checklist during the different stages like the preparation, submission, referring, editing stages of the paper publication process. Because it will really help improve the quality of the published research record. And also help expedite the integration of your data into the databases with more efficiency and accuracy. Also help to facilitate the long-term preservation, access, and reuse of the data.
Yep.
So that's it. Thank you.
Very cool. Very cool. A lot of resources here. And this will be really good for moving into the open access. Very cool. Very nice. I'm glad we published this article.
I'm glad you did too.
Tracy and Marion, thank you so much for walking us through this very pragmatic and useful article. Very cool. So this is August 30th, 2022, as we shoot this one. And let me ask, where do you think we go with this, let's say, over the next 2 to 5 years to have this more widely implemented? Are there different journals who are picking this up and moving on it? We're now entering the open access era, as we mentioned a couple times. Both in Europe and the US are now forming policies on open access. And how does this data preparation play into that? So just kind of, where do we go over the next 2 to 5 years? Can you imagine doing a data paper too? For example?
So on that data point, the data paper 2 part, so we did acknowledge in this paper that this would be an evolving document.
Great.
Because as you know, the journals publish new forms of data, or like, you know, as we receive feedback from the authors, we will, you know, keep augmenting this best practices. And when enough revisions build up, we actually plan to publish the updates to this original paper on archive.
Nice.
And we've also been in discussion with some publishers to have the instructions to authors have a link to this best practices document.
That's good. Yeah. Yes. Yeah, I could see that.
So yeah, actually, Monthly Notices has already included this in their instruction to authors.
Okay.
And we're working with AAS Journals to include this in your instructions to authors.
Well, thank you. Very cool. And I'll just throw out the other thing for those who don't know, we also do living articles. So if you wanted to do a version 2 of this, that could be part of this article, and it just becomes part of a living article. So we do those these days. Uptake hasn't been great on those, mainly because I think most people don't necessarily know about it. And it's not appropriate for all things, but maybe for this on best practices, maybe a living document is the way to go on this, if you want to do more than just archive.
Yeah. So I actually didn't know that we actually doing living articles now.
Well,
that would be
something.
Good...
Everybody's learning something.
I am learning it.
Yeah.
So yeah, that would be a good place to put the updates of this article.
Examples of other ones that you know have been used in the living articles are like LSST pipeline articles. Well, they will update the pipeline, so rather than put a whole new paper, it just updates on what is there. So anyway, it's an option to consider in the future. So very cool, very cool. So thank you so much, Tracy and Marion, for walking us through and giving us some wonderful guidance on best practices for data.
Thank you for inviting us.
All righty. Well, thank you so much. And that'll do, everyone. And I hope this made your astronomy day-to-day just a little bit better. And we will see you on the next one. Bye-bye.
Bye.